Hello, my name is Coco, and this is my final project presentation. I did obviously the data on fast food restaurants and all of the nutritional information with that. All right, so this is the data. Um, there was a lot of different categories, so I narrowed it down to just sodium and sugars. And sodium is measured in milligrams, and the sugars is measured in grams. I randomly sampled 30 values for this part. I won't read off every value, but you can see how I selected them randomly from a larger set. I chose sugar as the data that I'll summarize, and here is the histogram. At first glance, it does seem like right skewed, but it's actually bimodal. Some classes have zero frequency, like here, but then it picks back up again. It's just never quite as high as the first time, which basically means that there was a lot of things that had moderately low sugar, and then there was a lot of things that had like sky high sugar levels. So the mean of the amount of sugar in my sample is 19.9. The closest value in my data set to that is 20 grams, which shows up 3 different times. So standardized scores reveal that these 3 occurrences are the closest to the mean, with standard scores near 0. There's a lot of variation in my data. The coefficient of variation is over 100%. So that means that the standard deviation is greater than the mean. And this shows significant spread in the sugar content of menu items. As far as the outliers, I identified multiple outliers, which are really, really high in sugar. According to Chebyshev's theorem, at most 25% of data values will fall outside of 2 standard deviations, and I have 3 values beyond 2 standard deviations, which is 10% of my sample, so it does fit in with that rule. Okay, so for the hypothesis test, one of my questions was a hypothesis test for the mean amount of sodium in US fast food menu items. The claim was 700 milligrams, and my sample mean was 840.83 milligrams, which, with a test statistic of 2.06 and a p-value of 0.04802. So since the p-value is less than the significance level of 0.5, I reject the null hypothesis. It seems the amount of sodium is not 700 milligrams. Okay, and for the correlation test, for the sodium and sugars, I plotted sodium as the x variable and sugar as the y variable. Initially, the scatter plot showed a negative correlation due to the outliers, but after I removed the outliers, a positive correlation emerged, which I think better shows the representation of their relationship. So I was asked to estimate sugar content for 1,100 milligrams of sodium, which came out to 6.8858 grams. For 2,000 milligrams of sodium, the estimate is about 14.72 grams. The first estimate is trustworthy as it falls onto within the data range, and the second is less reliable since it involves extrapolation beyond the observed data. Okay, sorry if that was rough, but I appreciate you guys listening. Thank you.